Hello team, in this lesson we're going to learn very important topic in general for programming and especially for web development. I know that this topic is not very popular among other programming courses, and you wouldn't find the similar lesson in all other courses. I just can't understand why other tutors don't pay too much attention to this topic. And in my opinion, learning of OSI model should be the first thing students have to learn before starting learning web development and understanding web concepts. So today we are going to learn OSI model. We are going to start this lesson from the general overview of what OSI model is and what its primary goal. And I will explain you why we need to know OSI model and why I believe it is important. After that, we'll start focusing more on how OSI model works. During the lesson, you will learn that OSI is described through the 7 different and independent layers. So the rest of the lesson will talk about each layer in particular of the OSI model. And we are going to understand the goal of each layer, its functions, types of data passed through each layer, and examples of layer implementation. Namely, we are going to talk about physical, data link, network, transport, session, presentation, and application layers. After this lesson, it will become clear for you what actually IP is, why TCP IP often used together, what is HTTP, HTTPS, FTP, and other terms. Because very soon in this course we are going to work very closely with these concepts and you need to understand what they are. Let's start our lesson. Let's start from understanding of what OSI model is and why it was developed. The OSI model stands for Open Systems Interconnection Model. It is a conceptual model that characterizes and standardizes the communication functions of a telecommunication or computing system without regard to its underlying internal structure and technology. The OSI model was developed starting in the late 1970s to support the emergence of the diverse computer networking methods that were competing for application in the large national networking efforts in the world. In the 1980s, the model became a working product of the Open Systems Interconnection Group at the International Organization for Standardization. The model partitions the flow of data in a communication system into 7 abstraction layers, from the physical implementation of transmitting bits across a communications medium to the highest level representation of data of a distributed application. Each intermediate layer serves a class of functionality to the layer above it and is served by the layer below it. Classes of functionality are realized in software by standardized communication protocols. At the beginning of the lesson, I already told you that I believe that OSI model is super important. Most people in the IT space will likely need to know about the different layers when they are going for their certifications. Much like students who learn law needs to learn about the 3 branches of the power in the government. Because we are software engineers, not always we configure network manually. Not always we are dealing with physical servers, but we work with the system on different levels. And sometimes we work with those levels directly, sometimes indirectly. And I want my students to understand the big picture, at least on the high level, in order the knowledge that we are going to learn will be structured and you would understand what else stands behind the scenes. The understanding of the big picture helps with the problems troubleshooting when you want to understand on which layer we have issue. In other words, I can tell based on my experience, my life, and my understanding of the computer systems and especially web programming was not complete and not structured until I learned OSI model. That's why for all my students offline and online, I teach this lesson as a mandatory first lesson before we start learning web technologies. And on top of that, Time to time, we hear about the OSI model when vendors are making pitches about which layer their products work with. Let's start learning more specifics about OSI model. The OSI model is divided into two groups of layers: upper layers and lower layers. Like you can see on the slide, sometimes they are called host layers and media layers, or host and network layers. I read different sources of information, and as you can see, sometimes a group of layers called differently. In general, there are 7 layers. They are physical, data link, network, transport, session, presentation, and application. On the slide, you can see how these layers are grouped into two groups. The upper layer of the OSI model mainly deals with the application-related issues, and they are implemented only in the software. The application layer is closest to the end user. Both the end user and the application layer interact with the software applications. The lower layer of the OSI model deals with the data transport issues. The data link layer and the physical layer are implemented in hardware and software. The physical layer is the lowest layer of the OSI model and is closest to the physical medium. The physical layer is mainly responsible for placing the information on the physical medium. And now it is time to go deeper and talk about each layer in particular. And we will go in bottom-up direction. We are going to start from the physical layer and go further. Let's learn the key things about physical layer. The first thing that is worth to mention is the main function of the physical layer. It is to transmit the individual bits from one node to another node. As you already saw on previous slides, it is the lowest layer of the OSI model. It establishes, maintains, and deactivates the physical connection. It specifies the mechanical, electrical, and procedural network interface specifications. Let's understand now functions of the physical layer. The functions of the physical layer are: it defines the way how two or more devices can be connected physically. It defines the transmission mode between the two devices on the network. It defines the way how network devices are arranged. It determines the type of the signal used for transmitting the information. So, what kind of data is transferred on this level? Protocol data unit on this layer is a bit. I believe you know such digital format of data structure like bit. It is just 1 or 0. USB or registry jack, that is sometimes called RG, may serve as example of physical layer. That's it regarding physical layer. Don't worry, we are not going to learn how USB or RJ works. Understanding on this level is more than enough for this point in our course. The next layer that goes right after the physical layer is called data link layer. The key things you need to know about data link layer are: its main responsibility is the error-free transfer of data frames. Also, it defines the format of the data on the network. It provides a reliable and efficient communication between two or more devices. It is mainly responsible for the unique identification of each device that resides on a local network. Data link contains two sublayers: logical link control layer, that is responsible for transferring the packets to the network layer of the receiver that is receiving. It identifies the address of the network layer protocol from the header. It also provides flow control. And media access control layer. That is the link between the logical link control layer and the network's physical layer. It is used for transferring the packets over the network. Now, let's learn functions of the data link layer. The functions are: the data link layer translates the physical raw bit stream into packets known as frames. The data link layer adds the header and trailer to the frame. The header, which is added to the frame, contains the hardware destination and source address. Flow control is the main functionality of the data link layer. It is the technique through which the constant data rate is maintained on both the sides, so that no data get corrupted. It ensures that the transmitting station, such as server with higher processing speed, doesn't exceed the receiving station with lower processing speed. When two or more devices are connected to the same communication channel, then the data link layer protocols are used to determine which device has control over the link at a given time. On this layer, we pass such kind of protocol data unit as frames. A frame is a simple container for a single network packet. But what is network packet? A packet consists of control information and user data. The latter is also known as a payload. The payload is the part of the transmitted data that is the actual intended message. Hope I didn't confuse you even more. But just in case you have any question, please let me know in comments below the video, and I will be happy to answer. As example of data link layer, you can always imagine Ethernet. Ethernet is a family of wired computer networking technologies commonly used in local area networks. In simple words, this is a cable that you can connect to your computer for direct internet connection, instead of using wireless connection. Nowadays, it is even getting harder to find a laptop with Ethernet port in it. Another example of data link layer is a network interface controller, also known as LAN adapter. This is a computer hardware component that connects a computer to a computer network. Let's review the next layer. Right above data link layer, we have network layer. This is the third layer that manages device addressing, tracks the location of devices on the network. It determines the best path to move data from source to the destination based on the network conditions, the priority of service, and other factors. We already learned that the data link layer is responsible for routing and forwarding the packets. We learned this few minutes ago, and the routers are located on this level of the OSI model. The protocols used to route the network traffic are known as network layer protocols. Examples of protocols are IP, Internet Protocol. I believe that you already understood main function of this layer, but let's review its other functions. The layer provides a logical connection between different devices. A network layer adds the source and the destination address to the header of the frame. Addressing is just to identify the device on the internet. Routing is the major component of the network layer, and it determines the best optimal path out of the multiple paths from source to the destination. On this layer, we operate with such kind of data as packets. We already learned what a packet is. On the data link layer, we operate with frames. And frame is a simple container for a single network packet. On this level, when we route the data, we route packets. The most popular example of the layer is IPv4, IPv6, ICMP, that stands for Internet Message Control Protocol, and others. It is getting more interesting, do you agree? Because I believe you heard about IP addresses. IP address, this is exactly about network layer of OSI model and routing of network packets. Let's move on. The next layer is a transport layer. The key function of the fourth layer in the OSI model is to ensure that messages are transmitted in the order in which they are sent and there is no duplication of data. Transport layer has to transfer the data completely. This layer can be termed as an end-to-end layer as it provides a point-to-point connection between source and destination to deliver the data reliably. Let's talk about functions of this layer. The functions of the transport layer are: the transmission of data from source to the destination is happening not only from one computer to another computer, but also from one process to another process. There are multiple processes may be up and running on one computer. The transport layer adds the header that contains the address known as a service point address or port address. The responsibility of the network layer is to transmit the data from one computer to another computer and also to transmit the message to the correct process. When the transport layer receives the message from the previous layer, it divides the message into multiple segments, and each segment is assigned with a sequence number that uniquely identifies each segment. When the message has arrived at the destination, then the transport layer reassembles the message based on their sequence numbers. Following this rule, we can be sure that messages are transmitted in the order in which they were sent. The sender transport layer ensures that message reaches the destination without any error. There are two protocol data units that this layer works with. The received data from the previous layer is converted into smaller units known as segments. TCP works with segments. Packet segmentation is the process of dividing a data packet into smaller units for transmission over the network. Also, this layer may work with datagrams. UDP protocol works with datagrams. Datagrams are typically structured in header and payload sections. There are two probably most popular protocols used in this layer. They are TCP and UDP. Let's learn them. TCP stands for Transmission Control Protocol. It is a standard protocol that allows the systems to communicate over the Internet. It establishes and maintains a connection between hosts. Each segment travels over the Internet using multiple routes, and they arrive in different orders at the destination. The Transmission Control Protocol reorders the packets in the correct order at the receiving end. The main feature of TCP protocol is to ensure and confirm that message has been delivered. In case there is no confirmation that message has been delivered, TCP protocol resends data one more time. TCP is a reliable stream delivery service which guarantees that all bytes received will be identical and in the same order as those sent. UDP stands for User Datagram Protocol. It is an unreliable transport protocol, as in this case receiver doesn't send any acknowledgement when the packet is received. The sender doesn't wait for any acknowledgement. Therefore, this makes a protocol unreliable. UDP uses a simple connectionless communication model with a minimum of protocol mechanisms. UDP provides checksums for data integrity. You might be wondering, then why we have to use UDP instead of TCP? When UDP is applicable at all, UDP is commonly used for applications that are lossy. In other words, that can handle some packet loss, such as streaming audio and video. It is also used for query response applications such as DNS queries. Probably the best visualization of the differences between the TCP and UDP that I managed to find in the internet is presented on the slide. TCP cares about making sure that message is delivered to the receiver, and UDP just makes sure of sending all chunks of data without getting confirmation of receival and resending in case message wasn't received. But how message is delivered to the specific application on the computer that can run multiple processes and multiple applications in parallel? That is done with the help of the ports. But what is a port? I will explain now. A port is a communication endpoint. A port number is always associated with an IP address of a host and the type of transport protocol used for communication. It completes the destination or origination network address of a message. Specific port numbers are reserved to identify specific services so that an arriving packet can be easily forwarded to a running application. In simple words, port is an address of an application on the computer. So by this moment in our lesson we already know what IP is and what TCP is. But why TCP IP often used together? How this can be explained and what is the difference? Imagine that you need to deliver a mail to the receiver. You have an address. written down on the envelope. You know that you need to deliver mail to the specific address. You know the country, the city, concrete street, and concrete building. This is similar to your IP address. So with the help of IP address, you can find the destination for your message, the concrete computer, the device, joined to the network. But when you found the building, you discovered that it has a lot of apartments. Where is your receiver? Where you can find the number of the apartment. And different apartments are equivalent to different applications running on the computer. You need to deliver a message to the specific application. And the apartment number is a port number. So the port number is an apartment in the building. Is it clear so far? Now let's understand what is TCP. TCP in this example is a mailing service that delivers your message to the destination, ensures that message has been delivered, and confirms the delivery. Is it clear? TCP establishes connection between the sender and receiver. That's why we often say TCP IP protocol, meaning that we delivered message to the destination with the help of a TCP protocol and received confirmation about message delivery. TCP is used in conjunction with the IP in order to maintain a connection between the sender and the target and to ensure packet order. Is it clear now? Great, let's move on. The next layer in OSI model is a session layer. Why we need it? It is used to establish, maintain, and synchronize the interaction between communicating devices. Among different functions of the layer, it is worth to mention the next ones. Session layer acts as a dialog controller that creates a dialogue between two processes. Session layer adds some checkpoints when transmitting the data in a sequence. If some error occurs in the middle of the transmission of data, then the transmission will take place again from the checkpoint. This process is known as a synchronization and recovery. As a protocol data unit that is used on this layer, we use term data. It is any sequence of one or more symbols. RPC may be considered as one of the examples of session layer. RPC stands for Remote Procedure Call. It is when a computer program causes a procedure to execute on a different computer, which is coded as if it were a local procedure call without the programmer explicitly coding the details for the remote interaction. Wow, we already reviewed a lot. Hang on, 2 more layers left to discuss. The next layer is a presentation layer. A presentation layer is mainly concerned with the syntax and semantic of the information exchanged between the two systems. It acts as a data translator for a network. This layer is a part of the operating system that converts the data from one presentation format to another format. The presentation layer is also known as the syntax layer. Let's review the functions of the presentation layer. The processes in two systems exchange the information in the form of character strings, numbers, and so on. Different computers use different encoding methods. The presentation layer is supposed to resolve issues related with different encoding methods. It converts the data from sender-dependent format into a common format and changes the common format into receiver-dependent format at the receiving end. Encryption is needed to maintain privacy. Encryption is a process of converting the sender-transmitted information into another form and send the resulting message over the network. Decryption happening on the receiver side. Data compression is a process of compressing the data, that it reduces the number of bits to be transmitted. Data compression is very important in multimedia, such as text, audio, and video. The protocol data unit on this layer is the same as on the session layer. We work with data in this layer. ASCII, JPEG, MIDI are the most popular examples of this layer. All these are different data formats. MIDI for audio, JPEG for pictures, ASCII is an encoding for text. And the last but not the least layer that we are going to learn today is an application layer. An application layer serves as a window for users and application processes to access network service. This layer provides the network services to the end users. There are next functions of application layer. An application layer allows a user to access the files in a remote computer, to retrieve the files from a computer, and to manage the files in a remote computer. An application layer provides the facility for email forwarding and storage. So, with the help of the application layer, data transferring is happening from the application user interface to another application. On this layer, we work with any data. The most popular examples of this layer are HTTP, HTTPS, SMTP, POP, FTP, and others. I bet you heard these names, at least some of them for sure. We are going to have a separate lesson about HTTP, where I will explain you in details what HTTP is. In short, HTTP stands for Hypertext Transfer Protocol, to share hypertext documents in the web. HTTPS is the secured version of the HTTP protocol, its extension. It encrypts data on the sender side and decrypts data on the receiver side. It is encrypted using transport layer security, which formerly known as security sockets layer. Probably you heard about SSL. FTP is a protocol for sending and receiving files in the web. SMTP and POP, these are protocols to ensure a mail system working in the web. These are protocols of mail servers. So, do you remember example with the post service and the email? And the analogy we made with TCP IP protocol? So, where is the HTTP on this slide? The email, our message that we delivered to the receiver, and the specific format of the response that confirms delivery of our mail. That is HTTP in this example. HTTP defines how request response will look like, how the data will be described, and defines the contract for server-client communication. Very often, HTTP uses hypertext markup language to describe body of the message. But we are going to have a separate lesson about HTTP and you will understand what it is. HTTP is utilized to access websites, while TCP is a session establishment protocol between client and server. TCP is responsible for connection-oriented communication between client and server. HTTP is an application layer protocol that is request-response between client and the server. Is it clear now what HTTP is? Great! And that is all what I wanted to share with you today. Let's recap what we have learned in this lesson. We have learned so much useful things today that it will be hard to summarize on one slide. I hope you enjoyed the lesson today. We held an overview of OSI model. I believe it is clear for you what OSI model is about and what goals it has. We learned layers of the OSI model. In details, we reviewed each layer of OSI model with examples. Also, you know what TCP IP is, and I believe it is clear for you what HTTP is. This is important to understand because in my course for web developers we are going to deal a lot with these concepts. Thanks a lot team for your attention. Have a great day and see you in the next lesson.